Yeah. Hi, I'm Shao. I'm Shao Wang. I'm a Kubeflow maintainer for working group training and also in the section Streamline LLM fine-tuning on Kubernetes with Kubeflow Trainer. Due to the delay, I will speed up. So it be a mod. It might be a bit quicker. Yeah. So for data scientists, the expectation of fine-tuning LLMs is just write ML code and scale and fine-tune them on the Kubernetes, and they will repeat the procedure. However, they are not just the fine-tuning LLMs on Kubernetes is not just a thing for the Python code, but also about the Kubernetes itself. The reality is that the data scientists may suffer from the infrastructure pain. For example, they need to configure the compute resources and compute Docker images and data access. And maybe they need also to set up for the distributed environment and initialize the model and the data set, and maybe export artifacts or configure the gun scheduling and the resource queue. And this is not familiar for the data scientists, but they need to do the endless loop until they are right to run on the Kubernetes to scale their ML code and fine-tune the LMs. But that is not the data scientists want. And the challenge of the LM fine-tuning is that there are various fine-tuning techniques to choose from. For example, for fine-tuning, LoRa or knowledge distillation, data scientists may want to try all of them and quickly iterate for their ideas. And there are also some different distributed strategies to choose from, such as data parallel and the tensor parallel. Yeah, it may also affect the training results. And as the rise of LLMs and the models are become complex and have more weights and more weights signal from the 1 billion to 600 billion, and also they need to distribute large data sets across the training nodes. It's both of them need to modify any of them need to rely the training script. Yeah, that's the pain point for the data scientists. But what they want, I think the data scientists just want to quickly iterate on their ideas and change from different data sets and fine-tuning strategies while leveraging the ability of Kubernetes to scale their code. That's their pursuit is the simple, flexible, and scalable. Especially for the simple, the barrier is they need to configure some infrastructure configurations which they are not familiar with. That's the major point. However, Kubeflow Trainer V2 provide us with the ability to provide with the opportunity to mitigate the pain of the data scientists. In Kubeflow Trainer V2, data scientists only need to use the Python SDK to specify the chain job here, and DevOps engineers will manage the training runtime for them. What is the training runtime? You can simply think of it as a blueprint. Yeah, it provides a blueprint for the fine-tuning. And what data scientists do is just to override some of the configs in the training runtimes with the Kubeflow Python SDK, and the controller will combine train job and training runtime to create a job set, and the job set will create the fine-tuning job, and we'll build the LLM trainer on the top of the Kubeflow Trainer V2. Next, I will show you a demo of fine-tuning Llama 3.2 1B instruct with the Kubeflow Trainer V2. Yeah, it's official in the Kubeflow Trainer added in the recent days. However, due to the time limitation, and this example need to run up to 1 hour. So I will just show you the code. First, in this example, we will fine tune the Llama model with the alpaca dataset, which is very which is very well known. So I won't introduce them in details. First, we just need to install the Kubeflow SDK. Yeah. After installing the SDK, there are some prerequisites to use to fine-tune the models. First, we will need to install the official training runtimes provided by Kubeflow Trainer, and you can use this code to list the runtime. Yeah. And today we will use the torture Llama 3.2.1b for the example. And next, currently we need to create a PVC for models and datasets manually, but in the future we'll automatically create the PVC for storing datasets and the models downloaded from the Hugging Face. Yeah, we'll create a PVC with the Python SDK, and this is the response. And next is a major point. We'll bootstrap the LLM fine-tuning workflow. We just need to run this command. We will specify the runtime we use. It's torture Llama 3.2.1b, and specify the dataset and the model we want to use. And again, in the next, we need to specify some of the parameters we need to override to the runtimes. For example, the GPU we want to use. For example, we only use one GPU, and the data sets, the format is what we also need to specify. And we just run the code, and then we can watch the train jobs log. After run this code, we will create 3 ports for the LLM fine-tuning. The first one is the dataset initializer. It's the same as its name. It will initialize the dataset by downloading it from the Hugging Face. Yeah. And next, we will create the model initializer port, and it will download the model Llama 3.2 from the Hugging Face. And next is the trainer node. The trainer node is the place we do the LLM fine-tuning, and it will use the torture for the fine-tuning. You can see the log, and it may need 20 minutes. And we can get the fine-tuned model in the PVC. That's the workflow of this example. Now we're back to the PowerPoint. Yeah. So we can discover from the example that we can after the fine-tune the Llama model with Kubeflow LLM Trainer v2, we just need to write almost 10 lines of code to fine-tune it. And later I will give you another example for comparison. And also we can simply shift among different fine-tuning configurations, such as the GPU resource I showed you previously. Yeah, and we need the dataset need to modify their training script again. And also we will have the infrastructure complexity of Kubernetes and the LLM lifecycle for the data scientists. They just need to run the Python code. Also, this demo streamlines LLM fine-tuning workflow by integrating the model initializer and dataset initializer and the trainer node to one job set, and the data scientists won't manually configure them anymore. This is these notebooks, and you can find the example by scanning these examples, by scanning this QR code. Yeah, and now, initially we built our trainer on top of the Kubeflow Trainer v2. Yeah, Kubeflow Trainer v2 also support other distributed training frameworks such as JAX. Or JAX is under development, and it supports PyTorch, DeepSpeed, and MX for now. And initially, for the initial release of Kubeflow Trainer for the Kubeflow LLM Trainer, we only support the Llama 3.1.1b and the Llama 3.2.3b. And in the future, we'll add more models in the recent months. And I will show you the life cycle of the Kubeflow LLM Trainer v2. It's based on the Kubeflow Trainer v2. It's same as the MLOps engineers and DevOps engineers will manage the LLM training runtimes. And as I said before, it's a blueprint for the LLM fine-tuning. It will define many of the default settings we need to fine-tune LLMs. And the data scientists, which they are who are not familiar with the Kubernetes, and they also don't want to know the Kubernetes configurations. They just use the Kubeflow Python SDK to manage change job. And change job will use the fields, some configs defined in it to override the default configs in the LLM training runtimes, and they will create a job set. And the job set will create a storage initializer and a trainer. And storage initializer will do the initializer work for dataset and the model, and it will download it from the Hugging Face. And the trainer will create a distributed fine-tuning job. And in the end, it will be exported to the cloud storage by the exporter, which is not implemented yet. This is the workflow of the LLM Trainer v2. And I will show you an example about the history of our LLM Trainer v1. When we are in the LLM Trainer v1 era, and there is a conversation between data scientists and DevOps engineers. A data scientist asks the DevOps engineers, how can I fine-tune the LLMs on our Kubernetes cluster? And the DevOps engineer says that, aha, we have LLM Trainer v1 on our GPU cluster now. It looks like, yeah, it's a very long code, and there are so many Kubernetes configurations in it, and I think no one want to use this SDK for its long parameters and complex Kubernetes configurations. And the data scientist says, no, thanks. We will have a headache if using this. When the DevOps engineer asks, does it look good to you? It's powerful. It's powerful from the DevOps engineer's view, but not from the data scientist's view. However, when we are in the LLM Trainer v2 era, and the DevOps engineer said to the data scientist, hey, LLM Trainer v2 has been released. We are sure you will like it. A data scientist says, oh, really? How is the Python API looks like? And the DevOps engineer showed the data scientist with the API. It's more tidy and simpler than the API I showed you before. And we can make another comparison. Yeah, you can see this API is so long. And this API is just almost 10 lines of code. And the data scientist says, that's just the thing we want. How do we make it? And DevOps engineer said they make it by, first, as I showed you before, they separate the train job and the training runtime. It's the DevOps engineer's duty to manage Kubernetes related configurations and set up for the distributed env. And it will block and it will remove the parameters from the Kubernetes parameters from the API. So it will be more tidy for data scientists to use for the latter style of the Python SDK. Yeah. Second, we adopt the Torch 2 as a low-level runtime. We can see from here, Torch 2 adopts a recipe config architecture of command line. First is specify the recipe they use. For example, they will use this in this example. They will use LoRa strategy to fine-tune the LLMs on single GPU. And another is the config is about the model. Is about the model config. For example, the scheduler, the tokenizer, and other profile settings and distributed settings is all in the config. And it provides, and this architecture provides us with the opportunity to override default configs in training runtime with train job. In the official example, we can provide the overrides in the command line, and we also will define the default settings in the cluster training runtime. This is an example of cluster training runtime, and we can use the train job to, and we can use the parameter specified in the train job to override these configs, and we can fine tune the LLM with just these command lines. And a third, DevOps engine, we integrate the trainer node with model and dataset initializer and the model exporter. So it will automatically download the dataset and the model from the Hugging Face and do the fine-tuning work, and then export the fine-tuned model to the cloud storage. So data scientists won't manually download the dataset and launch the fine-tuning job and export it to the cloud storage. With Kubeflow LLM Trainer v2, this is we manage this lifecycle for the data scientist. So we streamline it to a single workflow without interrupt and manual involvement. And four, we provide simple yet flexible Python SDK with just 4 parameters rather than so many parameters for data scientists. So the data scientist says it's amazing. DevOps engineer says, aha, enjoy your journey to Kubeflow LLM Trainer v2. That's what we do in the past 6 months. So there is a summary for this section. So we provide a simple yet efficient Python API for data scientists, and we hide the complexity of Kubernetes configurations. And the Kubeflow LLM Trainer v2 is built on top of the Kubeflow Trainer v2 and Torch 2. So, and it's streamline LLM fine-tuning workflow on Kubernetes by integrate the model initializer, dataset initializer, trainer node, and the model exporter. And the last, it allows users to gracefully shift among diverse models, datasets, and fine-tuning techniques and distributed strategies. And they won't need to write the specific fine-tuning scripts. They just need to use our SDK. And in the future, we'll add more support for the fine-tuning strategies such as LoRa, QLoRa, and DORA. And we will add more post-training techniques such as knowledge distillation and reinforcement learning. And we also need to add more models such as Llama 3.3, Llama 4, and Qwen3, and maybe DeepSeek in the future. And also we'll add a model exporter for the checkpointing to export the models to the cloud storage. And we also automatically create PVC for the data scientists, which is not implemented yet in the demo I showed you previously. And also we'll support parallel model and dataset initialization, which is not implemented yet also. And we'll collaborate with the job set community to achieve this. And we'll also add more notable use cases to flourish our user ecosystems and provide reference to the users. And how to get involved? You can scan this code to join our AutoML and training work group meeting. And you can also join the CNCF Slack. If I will upload this PowerPoint to the Slack channel, after the symposium. And you can also participate in the Kubeflow LLM Trainer development if you are interested in it. And the meeting bi-weekly and the AutoML and the training work group meeting is held bi-weekly on the week Wednesdays 2 p.m. and Wednesdays 5 p.m. in UTC time zone. And that's all. Thank you. You can reach out to me if you have more questions. And this is my GitHub IDs and Slack channel and LinkedIn. And also I'm seeking for an MSc PhD in North America in 2027. If you have proper opportunities, feel free to contact me. Thank you.
Awesome. Thank you so much. Yeah, it looks like we got 4 minutes for questions. Anyone have any questions for Shao?
Yes.
Let's see if we have any in the chat. Nope. Final call for questions going once, going twice. Perfect. Awesome. Well, thank you so much, Shao.